Hi, Lauren. I heard your team developed a new app called Sherlock. What is it?
Nice question. Our team is currently working on RWE studies. Real-world data is very different from traditional clinical trials. We developed this application to facilitate data review, summary, and analysis.
In 2021, I started to develop this program as my summer intern project. The initial goal was to create a dashboard to monitor the status of real-world data, such as missing percentages of critical assessments for propensity score matching.
In 2022, we have made significant enhancements and improvements to Sherlock. Now, Sherlock has been transformed from a simple data dashboard app into an integrated toolset for real-world evidence studies and real-world data. In this year, we have been closely working with end users and added multiple new features to improve the app for data review, summary, and analysis. Welcome to Sherlock, our secret weapon for real-world data visualization. It is a great tool for data review, processing, and analysis in real-world evidence studies. Sherlock contains features of help determine confounder lists, harmonize units for lab assessments, detect outliers, review and determine line of therapies, cohort selection, generation of propensity score plots and tables, evaluate trimming methods for IPW datasets, check covariate balance tables, and dynamically generate demographic tables, and last but not least, a table validation tool. Let's start to hear some user experience from our statistician Mia, who recently used Sherlock to review data for one of our real-world study, CLL.
The real-world data could serve as control arm for single-arm trials to satisfy substantial evidence standard for product approval. Unlike randomized clinical trial, the limitation of real-world data collection process could lead to unstructured and messy data, especially the lab measurements. To align the real-world data as close as possible to clinical trial data review is important and time-consuming. But thanks to the real-world evidence programming team, we have Sherlock now, which greatly improves this process and helps our next step decision-making.
Let's take the lab assessment as an example. After importing the lab dataset, user can select the corresponding variables for each of those below sections, including subject ID, parameter, unit, etc. You will be able to check the missingness of lab assessments, the corresponding units from different vendors, and the range or extreme values of the lab measurements. Click the Missing Percentage tab. Sherlock will show the number and percentage of missingness for each lab test. We may find prognostic factors here, and their missing rate could help us prepare next step analysis. Based on specified missing threshold, we might rule out variables with high missing percentage, that we won't impute these variables nor use them in the PS model. For example, the beta-2 macroglobulin, which is a prognostic factor for CLL RWE product with high missing percentage. Moreover, if we find too many prognostic factors with high missingness here and leave us with very few prognostic variables, then we might skip model selection and adjust all qualified prognostic factors in the PS model. To click the Assessment Unit tab, Sherlock will present all the unique units for the lab test, which helps on standardizing lab results units. Every data point is precious for RWD. We'd like to utilize data points as much as possible. For variables with unit NR, it's important to further investigate and figure out how to handle such cases. We can take CLL real-world evidence study as an example. Let's do a simple filter on ALC. As you can see, there are 7 different units for ALC and one of them is NR. Then we'll need more details by using Summary tab. It allows you selecting the ALC with unit NR. It will show you how many records with unit NR and the statistical summary. minimum value, maximum value, mean, etc. The box plots are also provided by Sherlock at the bottom part of this tab. With Sherlock, we could dynamically and intuitively see what the extreme values are and how the extreme value changes the distribution of the RWD. There is the range filter at the top of the page for you to select the range, and the summary will update it accordingly. You can also use this automatic method based on IQR to exclude extreme value. After review the CLL lab assessments with clinical team by using Sherlock, we'll be able to discuss and decide how to handle the NR unit and extreme values.
Sherlock is also featured to help with cohort selection. After loading in the ADSL dataset, user can see the subject level data and apply filter onto it. In the Inclusion and Exclusion Criteria tab, users will be able to build an attrition table based on the variable and the criteria they select. Also, the dataset will be updated accordingly. In the next Missing Percentage tab, users can review the missing percentage based on their selection of variables between treatment groups. This can help STAT and SP team to make decisions on the co-founder list. Another very important key feature of this is that if you update anything in the Inclusion and Exclusion Criteria tab, it will be automatically updates the results on this Missing Percentage tab, so that it is easy to check or change the co-founder list for each subgroup's output. And in the Summary tab, similarly to the Lab Assessment section, it will show the statistical summary and also the plot based on the variables users select. In Sherlock, we have this demographic table builder, which can help users to build demographic table dynamically. To do so, user just needs to simply upload an ADSL dataset. The Sherlock will then automatically identify all the variables from the dataset. Next, user will select the treatment group variable and auto summarize the variables they need for the demographic table. A demo table will be generated on the bottom of this page for the user to review and download. There is also this Show Total column option to let the users to choose whether they want to contain a total column in the output. A new feature we added recently is the filter function. With this function, users now can generate demographic table dynamically by filtering ADSL datasets. User can choose what variables they want to apply a filter to, and they can select more than one variable. After applying the filter, a new demographic table will automatically update it.
This tab aids clinicians in reviewing patient treatment regimens and determining lines of therapy. The first page shows an overview of the data uploaded. The second page shows a treatment graph. The time periods for each treatment can be easily seen. The start and end dates are labeled for each, and hovering over the bars will show the duration. The outcomes and corresponding dates are also shown and labeled. Tables are found below, displaying the same treatments and outcomes as the graph. According to the reviewer of the data, treatments can be combined into the same line just by editing the table. Outcomes can be moved in a similar fashion, and comments can be added to each row of the table. These changes will be preserved if the tables are downloaded. Next, Mark, a statistician, will discuss his experiences using Sherlock and analyzing propensity score distributions.
Multiple imputations and propensity score methods are commonly used in real-world studies to address missing values in real-world data and to balance an external control arm to the clinical arm. Sherlock's features provide the unique tools needed to help statisticians assess the balance after a propensity score adjustment. This dashboard visualizes summary statistics of the propensity score values by imputation. These box plots allow for easy review of the propensity score distribution for each arm and the ability to quickly identify any outliers or extreme values. Sherlock also helps statisticians explore the impact of different trimming methods with only a few clicks of a button. As different options are selected, the resulting box plots are updated live and show the differences between trimmed and original values. And finally, after the propensity score values have been checked and possibly adjusted using these tools, Sherlock produces summary tables to easily assess the resulting balance between the external control arm and the clinical arm. This dashboard instantly calculates the standardized mean difference for each covariate before and after adjustment. Sherlock's streamlined dashboards have made it possible to more efficiently validate propensity score distributions and ensure a balanced cohort for subsequent comparative analyses.
Survival plots can be generated by the app based on uploaded ADSL and ADTTE datasets. After the appropriate variables are selected on the first page, a Kaplan-Meier plot will be displayed. By changing the parameter selection, the survival probabilities of different populations can be viewed. Sherlock contains the functionality to validate RWE tables. A variety of tables are generated by the RWE team for different studies. Typically, in order to validate each table, a different programmer would have to write a SAS program to generate their own version of the table, and the two are compared. Sherlock can act as a validator, reducing the need for developers to write additional programs. To perform table validation in the app, the user first selects the study folder of choice. Then the app reads through the folder structure and locates the Excel tracking file. This file contains the title and footnotes for each table, as well as information regarding the location of the developer programs. The user can select the subset of tables to validate, and then click Start Validation. Once the app has finished processing, it will list each table that has been validated along with the passing status. The green checkmark indicates no differences between the primary output table and the validation table. Clicking on the checkmark brings up a pop-up showing the two tables, and the field above tells us that there were no differences found. The second row has a red X as a status, indicating differences. Clicking here shows us a summary of where the difference was found, and scrolling down, the cell of the difference will be highlighted in the validation table. This tool speeds up the processing for performing table validation and leads to quicker turnaround times for reviewing and finalizing tables.
So what is your plan for the future?
In 2023 and beyond, first, we will work with IT to deploy this application to DaVinci platform to allow broad team access. Second, we are going to execute the user cases in CLL and follicular lymphoma RWE studies. And finally, we will try to expand the capacity to other studies and the EBR requests, such as the CAR-T registry study.
Hello, I am Grace John, and I'm 6 years old. This year, I'm learning how to do ice skating, and I'm good at it. And I can build this Lego all by myself, all by myself. Are you learning something new this year? My dad is working for the other kids who are sick, so they can come home and play with their parents. So, who are you working for? See you next year. Bye. But am I too good at it?
Yes, you're good at it. Yes.